This video is going to cover the basics of AutoLISP, programming using LISP in AutoCAD. So let's look at our objectives here. First of all, we're going to be able to define common AutoLISP terms so that when I'm discussing new terms throughout this lecture, you'll be able to understand what I'm talking about. We're going to also identify common data types associated with AutoLISP. We're going to use the Visual Lisp editor to write simple routines and load them into AutoCAD. And then we're going to learn how to load, use, and save those routines so that we can use them in later sessions of AutoCAD as well. So let's start off with some terminology here. A list is anything associated with in a set of parentheses. Lisp is a simple word that means list processing. So anytime you have a set of parentheses, everything inside of that set of parentheses is considered a list by AutoCAD. And this is the reason why in Industrial Drawing 12, when you first started with AutoCAD, if you started, inputting points, X, Y points with parentheses, it gave you an error message. And it's because you were inadvertently telling it to run a Lisp routine, and it didn't want to do that because you didn't know what you were doing. So that's why we don't use parentheses when we're inputting points, just like drawing lines and circles and that kind of thing. But anytime we want to run a Lisp routine, we do include parentheses. So parentheses are very important to AutoCAD, to AutoLISP. An atom is any individual item within a list. And there's a few different types of items, but any separate item is an atom inside of a Lisp routine. A function is basically the commands inside of AutoLISP. Typically, they're the first element within a list. An argument is any element that follows the function, and they are passed to that function. So arguments can be very specific data types depending on the type of function that you're working with. An expression is a list that involves a function and usually arguments. There are a few different data types. First of all, there are integers, which are whole numbers with no decimal points. Think counting numbers 1, 2, 3, 4, 5, or like rows and columns in an array. You can have a whole row, but you can't have a half a row. It wouldn't make sense to have 3.5 rows in a column, or in 3.5 rows in an array. Real numbers are floating point numbers. They always have a decimal point. So 3.75, 2.24, whatever it happens to be. Strings are words. When you're talking to somebody, you're going to put it in quotation marks. Strings are always enclosed in a set of quotation marks. And then, of course, lists. We talked a little bit about this already, but AutoLISP stores point coordinates or XYZ values within a set of parentheses, but more specifically, not within a set of parentheses, but more specifically as a point list. Okay, so when you think of X, Y, and Z, they're 3 numbers, but they're not necessarily involved or enclosed in parentheses. So LISP stands for list processing. You're going to give it a list. It's always going to try to return information to you. And we'll see this in a few minutes, but one of the important things to remember is that when you run LISP, AutoCAD is always going to return some type of information to you. Everything you place inside of parentheses is a list. The first atom in a list is the function. The second and any other items in the list are arguments. So let's look at some basic Lisp rules here. Number 1, your parentheses must be balanced. For every open parenthesis, there must be a closed parenthesis. If you don't do that, your Lisp routines will not work. Quotation marks must also be balanced. So if you start talking to somebody with open quotation marks, you have to tell them you're done talking to them with closed quotation marks. When you're entering number, any number less than 1 but more than -1 must begin with a 0. So like if you can't just put like 0.5, you have to put 0.5. If you don't remember that original 0, it'll give you an error message, and we'll come back and talk about that in a couple minutes. So we have an example here. This is a very simple Lisp statement here, set q BDX to 0.25. If I want to set q BDX, if I put just 0.25, it's going to give me an error message. So it has to have a 0 in front of it there. Syntax. Syntax is the order of which you say things, and it doesn't make sense necessarily until you think about how AutoCAD thinks about things. So anytime you're writing a Lisp routine, the function is given first, followed by any necessary arguments. And I say necessary because there may be times when you can just give it a function and not give it any arguments. So your format here is open parentheses, function, and then argument, 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 and then when you're done with however many arguments you need, close parentheses. All of the items in the list are separated by spaces. The number of spaces in between arguments doesn't matter. So you could have 1 space in between arguments, you could have 2 spaces, you could have 10 spaces. It doesn't matter. It just sees that a space is what separates the arguments. Anytime you have 2 quotes together, like open close quote, that's going to indicate an enter key, like somebody pressed the enter key at the command line. So let's look at some mathematical functions. An easy way to kind of get familiar with AutoCAD is to just look at some easy mathematical functions. So looking here, our Lisp format, open parentheses plus, and then number, and so however many numbers you want, and then close parentheses is going to give you add, then you've got subtract, multiply, and divide. So for example, here we have open parentheses plus 3.0 and 2.5. If you add 3.0 and 2.5, you get 5.5. If you say subtract, you have open parentheses 7.25 and 3.75. It's going to subtract the second number from the first number. And so 7.25 and minus 3.75 is 3.5. The third one there is multiply. So multiply 5.0 times 8 is 40.0. And then the last one in the list here is divide. If I divide 12 by 4, I get 3. Notice that the last one in the list there, all 3 numbers are integers. So if I put integers into the equation, I'm going to get an integer out of the equation. If I put real numbers into the equation, I'm going to get a real number out. And if I mix them, if I mix real numbers and integers, I will get real numbers out. So functions with real numbers return real numbers. Functions with a mix of real numbers and integers will return real numbers. And the last example there shows an integer because both of the arguments in that last function are integers. So I'm going to switch over to AutoCAD here, and we're just going to practice this on the command line. Notice down I've got the command line down here. I can say open parentheses, telling the computer that I'm running a Lisp routine. I can say add, and then 3.0 and 5.25, close parentheses to tell it that I'm done. They have to be balanced. Enter. Notice that it returns to me on the command line the information 8.25. If I open parentheses and I say, okay, this time let's add 3 numbers, 1.0, 2.25, and 3.625. It's simply going to add those 3 numbers together and give me the result there is 6.875. Now, when I do things like subtract, if I say subtract 12 minus 6, if I were to put another number in here, 2, close parentheses, 12 minus 6 is 6, 6 minus 2 is 4, so when I press enter, you'll see that that the command line returns 4 to me. If I were to continue that and say subtract 12 and 6 and 2 and then something like 8, close parentheses. Okay, so now 12 minus 6 is 6, minus 2 is 8, or minus 2 is 4, and then minus 8 is negative 4. So when I hit enter here, you'll notice that I get negative 4 on the command line. So it just continues to run it right down the string there. You can also nest functions inside of Lisp routines. So parentheses may be nested inside of each other. Think of groups, exponents, multiplication, gems, right? When you're doing mathematical functions, it's very much the same inside of a Lisp routine. So AutoLISP, just like gems, just like mathematics, works from the inside out to complete the program. So if we look at an example here, if I have this example, it's going to work from the inside and then out. So it's going to do add 3 and 4, which is 7, and then it's going to multiply that times 5 to give me 35. If I do another one, it's going to say multiply 2 times 3.5, which is 7, and then it's going to subtract 7 or 6 from 7, and so I'm going to get 1.0. Notice that I'm mixing real numbers and integers here, so it's going to give me a real number as a result. The third example, I've done a couple of nests here. I've got add 4 plus 4, which is 8, and then multiply that times 3, which gives me 24, and then divide that by 2, which gives me 12. So if I go back to AutoCAD here, and we just practice that again, I say open parentheses, and I can say, okay, let's multiply, and then I'll say open parentheses again. I'm going to add, say, 2 and 3, close parentheses, and I'm going to multiply that times 5, close parentheses. So 2 plus 3 is 5, times 5 is 25. When I press enter, you'll see on the command line down here that it gives me the 25 as a result. You can nest as many as you want, as long as everything is balanced and you have written valid functions. Now, there will be times inside of Lisp routine that you'll want to store information, and you can use setQ to do this. Any type of information may be stored in RAM, in random access memory, for future use. It's only going to be stored in the active drawing session. It's not going to be saved, so you can't use it that way, but anytime you're in the active drawing session, it can be used over and over again. And you're going to use the setQ function to store this information. So your format, if we look at this, is your setQ variable value. Okay, so it starts off with the setQ as the function, and then the variable, and then the value that you want it to have. The variable, this middle part here, can be any combination of letters and numbers. So what I'm doing is I'm going to say, okay, I want to setQ, okay, which means set equal. I'm going to set equal a variable. I could call it, x1 or ab2 or anything I want, and then give it a value and put it in there. And that variable can be any combination of letters and numbers. The value could be a number, it could be a text string, which of course, because it's text, it's got to be enclosed in quotation marks, or it even could be an object inside of a drawing. But the variable, if we think about the variable, it can't just be a number. It's got to have a letter along with it. So, P1 would be a valid variable, but 1 isn't a valid variable because it has a value all by itself. When you're creating variables, I suggest that you create variables that have meaning. Don't just create variables like A, B, C, D, E, F, G, because later on it may not make any sense to you on that. So if I go back to AutoCAD here on the command line, and I want to create some variables just for fun here, I'm going to say open parentheses setQ, which means set equal, and then I'm going to give it a variable. So I'm going to call the variable name, just for the sake of creating a variable here. And then I'm going to say, I'm going to give that name a value, and I'll call it Rigby. Now, because this is text, it's a name, it's a text string, I have to put it inside of quotation marks. Then I can do close quotes, and when I press enter, what happens is on the command line, it returns the value to me, Rigby. But inside of AutoCAD, inside the database, it created a box, if you want to think about it. It folded up a cardboard box, and then inside of that box, it put, on the outside of the box, it wrote the word name, and on the inside of the box, it put the value Rigby, okay? And it's going to stay inside of there until I close the drawing or close AutoCAD or the power goes out or whatever. It's going to just stay inside of that random access memory. It's not stuck. We could get rid of it if we wanted to, but it's just hanging out. It doesn't take up much space, so it's no big deal. Okay. If I wanted to create another one, let's say I create another one, I say open parentheses, again, set Q, which is set equal, I could call it R1, and then I could give it a value like, say, 3.25. Okay, close parentheses. So again, what I'm doing here is I'm saying set Q, set equal, and give that, that, if you want to call it a box, create a box. On the outside of the box, write R1, and on the inside of the box, we're going to put the value 3.25 and press enter. Notice on the command line now, it represents, it says, okay, 3.25. Now, if you want to see what's inside of a box that's already created, you got to do what they call bang the box, right? So the way you do that is you hit from, now this one is not in parentheses, it's not a Lisp routine, but if I want to see what's inside that variable, I do the exclamation point, and then I could say name, since I called it name, press enter, and you'll notice that it gives me that value back, saying, hey, we found that box, it's got Rigby inside of it. Or if I do the same thing for R1, I bang the box, it was R1, press enter, and it says 3.25. So what's written on the outside of the box stays the same, but I can change what's on the inside of the box. So if I wanted to change it, I would just do another set Q. Set Q name. Right now it's set to Rigby, but I could set it to whatever I want. Again, I'm going to put it in, since it's going to be text, I'll put it in quotation marks, and I'll put Joe student. Okay, notice that I can have spaces here when I'm doing this. Close parentheses. And now I've taken Rigby out of the box, and I've put in Joe student inside the box. And you can do this, like I said, for just about everything, every type of value in AutoCAD. You can hold integers, you can hold real numbers, you can hold text strings, and in a little bit we'll even talk about how you can put an object into a variable if you want. Next thing we want to talk about is communicating with the user. There are several commands which may be used to communicate with the user. Most of these, or many of these functions, begin with the word get. Okay, so you're telling the user get this or get that, and it's going to communicate with the user in some function. And these are generally referred to as get XXX functions because the get stays the same and then XXX will change. They also allow the programmer, that's you, to include a message to the user. For example, getInt will allow the user to input an integer. Remember, an integer is a counting number, 1, 2, 3, 4, 5. So this is a simple line of code where it says set Q NOS. Okay, so I'm creating a variable. I'm calling it NOS, which might be number of sides. Open parentheses. Here I am nesting one Lisp routine inside of another. Get an integer, get int, open quotations, because now I'm talking to the user, enter the number of sides, close quotation, close parentheses for this inside one, close parentheses, insert in for the second one. So it's going to create a box called NOS, and then it's going to prompt the user to put in an integer. And if the user tries to put in something that's not an integer, it's going to give an error message to that user. So if I come in here and I do that and I say, okay, let's do this set Q NOS for number of sides, and then I'm going to nest inside of this the get integer. Okay, and I want to prompt the user to enter the number of sides. And if this was like number of sides on a on on a polygon, for example, you can't have 3.5 sides again. So it would make sense that it has to be an integer. Close quotation, because it is a text string. Close parentheses for the first set, close parentheses for the second set, and then when I press enter, it's going to ask me to enter a number of sides. So now I can put in a number. I could put in 1, 2, 3, 4, 5, whatever it happens to be. But if I try to put in something like 5.5, it says, hey, you can't do that. It requires an integer value, okay? Because there's no such thing as 5.5 sides on the polygon. So then I could say, oh, well, it's got to have 6 and enter. And now I've created that box, and inside that box is that value of 6. The command function. So you want to be able to run commands when you're working inside of AutoLISP. So this is going to allow us to do that. Information stored in the computer may be used in Lisp routines to complete various activities. Draw lines, circles, arcs, polygons, erase things, move things, array things, whatever it happens to be. The command functions allows you to access those AutoCAD commands. Your format here is the command, okay? Command is the function, and then argument, argument, argument. The number of arguments depends on the command. Some commands, like circle, only allow 2 arguments. So it'll allow 3, but it'll have 3, so it'll be command, circle. The second argument will be the center point. The third argument will be the radius of the circle. But depending on the function that you want, or the command that you want to run, it's here. So your function is command. The second argument is going to be the command name. The third argument is going to be input that the user would put, the fourth argument, and so on. The number of arguments is determined, again, by the command you use and your intended purpose. Now remember, anything that would be typed at the command line must be held in quotation marks because it's a text string. So that includes the command name itself. If I want to run the command circle, the word circle has to be inside of quotation marks. If I want to run the command polygon, the word polygon has to be in quotation marks. So if we look at an example here, let's consider the following code. Set Q. I'm creating, and this is just code. It's an excerpt maybe of a longer routine here. Set Q creates, set equals CTR. So create a box called CTR, and then get point. So then I'm talking to user, select a center point. Okay, so it creates a box, and then the user selects a center point, either with the mouse or by typing in, an XYZ coordinate. The next one says set Q rad1 get distance. Okay, this is another one of those get functions. Get a distance. The CTR right here tells the computer, hey, measure from this point created here and make the rubber band. Okay, and we'll show this in a little while when we come back to actually programming this. Specify a radius, and then this is the last one here, command. Okay, this is our function. We're going to draw a circle, so circle has to be in quotation marks because that's what you would type at the command line. And then CTR is this first variable, and rad is this second variable. It should be rad1. So then what happens is it says, okay, you want to run the circle. It finds this value, it puts it in there. It finds this value, it puts it in there. It draws your circle and exits the command. This concludes the first part of this lecture. I'm going to conclude the second. I'm going to go to the next part, and we'll create that in a second video.